find the sum of the geometric series. It's going to be 5 minus 10 over 3 plus 20 over 9 minus 40 over 27. This problem tells you you have a geometric series. It kind of already tells you that it converges because it says find its sum. You can only have a sum if the series converges. So it's already telling you that it converges. But let's make sure that we know why it converges. What's the first term in this series? What's A1? 5. But that's really what I'm calling A. A represents the first term in my series, so I'm just going to call that A. Okay? So now I need to find R. This is a geometric series. I should be able to take each number and multiply by something to get the next. It's not so obvious because we have fractions. Makes it a little bit harder. What you do is you take the next term, so for example, take the second term, negative 10 over 3, and divide by your previous one, which was 5. What do I get if I simplify that fraction? Negative 2/3. And you can do this with any pair of numbers in this series. If I take 20 over 9 and divide by negative 10 over 3, you're going to get negative 2 over 3. If it's a geometric series, this should be the same number every time when you're taking the next term and dividing by the previous one. So this value here is R. So R is going to be negative 2/3. That's your, R is called the common ratio. Okay. So remember our condition on R in order for the series to converge. What was the condition? The absolute value of R had to be less than 1. What do I get if I take the absolute value of R here? Absolute value of negative 2/3. 2/3. That's less than 1. This tells me, if I didn't already know, this tells me that this series converges. And now, to find the sum, which is what it wanted me to do, I've got to use that formula from before, which was A over 1 minus R. That's the formula for my sum. The sum of this series is A over 1 minus R. A was 5, we said. R was negative 2/3. So what's that become? 5 over what? 5/3, right? 5 over 5/3, which is equal to 3.